Hello, everyone. Welcome to our first Ask Beth Anything.
Hello. Hi, everyone. How are you? I think we've just connected the audio. I think we're actually starting. Okay. Could I just confirm, are you able to see me or hear me? You just heard and saw Isha. By the way, if you're wondering how to talk on this, the way to talk on this is to go to the website live.poshenlo.com/show, and then you can type anything you want inside. But I see that people are typing. Yes, so it has gone across. Very good. So what you'll see here is that this is a much more modern version of the Ask Math Anything that was started on this channel about 2 years ago. In fact, 2 years ago when the pandemic broke, one thing that I did is I decided to try to show up every day to answer any questions anyone might have about mathematics. And that was tons of fun. I did that really every day until I got busy working on something to help save people from pandemics. But now, 2 years on, we are thrilled to have, actually not me, but a huge number of brilliant high school students who I've had the real pleasure of working with. And they are now going to become our co-hosts for this Ask Math Anything. In fact, yes, the Warrior Cats, you can already start asking math problems because we're going to be collecting all of these problems. And right now is actually a good time to start asking them because our two co-hosts, who I'll introduce in a moment, are going to be answering any questions that you have. But I want to say a little bit about how this is structured because we haven't run anything like this for 2 years. The way this works is that people can go and ask any question that you're interested in math, and our co-hosts are going to pick questions to discuss and solve together. They're collaborating on this, and we're going to choose questions that are around the algebra or geometry level, if at all possible, ideally around algebra or geometry level for people doing math contests. But by the way, if you ask other questions, of course, they may jump in. We also have a lot more high school students sitting in the back as moderators, and we just like fun questions. Now, the reason we're doing this is we want to show that math is something which is fun when it's explored fresh. And we are just so lucky to have such brilliant people to lead these live streams who can solve these questions fresh. Now, actually, the fun part, by the way, is that some of the people who are leading these live streams are people who watched the Ask Math Anything about 2 years ago. So it just shows that time flies. Well, without further ado, let me say a little bit about our co-hosts. Today, we have two incredible people. We have Maggie and we have Isha. They're both very interested in math, science, and so on. Of course, there's much more you can learn about them if you click underneath on the live.poshenlo.com/show page. But some brief things: Maggie is about to start at MIT as a student, and Isha has been doing lots of things, not only math, also robotics and engineering. And in fact, she was one of the people who contributed some of the code that is powering the website you're on right now. But without further ado, I'm going to step back and hand it over to our co-host to lead the rest of the show. You won't see me anymore, but you'll see them, and that's much better.
All right, thank you so much, Professor Lowe. Welcome, everyone. We're so excited to be here. And I guess if y'all have any questions, we're happy to answer them.
Yeah, definitely. And I see there's one question already from Ivan. I guess I could put it on the screen, but it looks like calculus. So I'm not sure. Isha, do you want to do it or?
I feel like it's like a little bit too advanced for this live stream, but we can definitely give you some tips on it. So because like you talk about like f prime, which is typically signified of derivatives. So that's just, I guess, like a hint towards that. All right. Oh, I see a very cool question in chat from Pi. In a regular pentagon, so I'm just gonna, okay, that is not a really good pentagon. There we go, that's much better. Point M, okay, A, B, C, D, E. We have M on side AE. So it's the midpoint and it goes to segments AC. Oh, you have a segment AC, perfect. And if we know that, oh, there we go, okay. I think I got my diagram straight. And then this is 3. What is the value of AB? Okay, I have a really messy drawing, but I think the really key point here is the fact that this is the midpoint. Because like my suspicion is that there's like you use the, I forgot what it's called, but like AZ times CC is equal to MC times CB somehow.
Oh, PowerPoint? Or is that different?
Oh, yeah. Exactly. But it wouldn't get us, but it doesn't use the midpoint. So I guess that's like the difficult part of this. Maggie, do you have like an idea?
I'm not sure. Does anyone in the chat have an idea maybe?
Okay. Well, we could definitely like probably use like the area of a triangle or like similar triangles with this, because if we because we're trying to find AB. So if we do something like this to this bigger triangle or something like that, but because it's a regular triangle, which means that like this side A to M times like 2 is equal to A to B. All right. I see Pi says maybe similar triangles. Yeah, that's definitely like what I was thinking, because you know the midpoints are definitely like very intentional here. All right.
I think some people, we could see if anyone in the chat has any ideas. But if not, we can also come back to the problem too.
Okay. Oh, Kensley says there's the 2/3 rule in some triangles. Yeah, that's definitely like a really good point. I'm pretty sure that's with isosceles or isosceles triangles, which could work here, though we don't quite know whether M to B is equal to A to B. Oh, hey, I just noticed something. A to B is just 2 times A to M. So if we're able to find out what A to M is, then we can just times 2. Well, I wrote that down, but like I didn't make the connection. Okay, so oh, it says I think A to Z is 3. Yeah, there's like a weird line there. So my diagram drawing skills are not the best, but it's supposed to signify that A to Z is 3. Okay. So as someone said, AC over AB is equal to the golden ratio. AC over AB. Wait, that's actually really cool. How did you get that?
Oh, maybe trig or something? Because ACD is like, you could probably use trig on that. I'm not sure though, but that is a very cool fact.
Oh, totally. Oh, speaking of trig, we know that the like angle sides are like 108 degrees, right?
Mm.
Yeah, so could that be used somehow? All right. Okay. If y'all like have ideas in chat, like it'd be like super helpful. I think that similar triangles is the key here, though.
Yeah, definitely. Especially with the golden ratio hint.
Definitely.
Kelsey says, is there a way to get angle ABN?
ABM.
Hmm.
I think that's an interesting thought, because if like the whole angle is like 108, then that means if we split it like halfway, which should be EB, if I'm not mistaken, then that would be like 54, and then split that again in half.
Yeah. This is a pretty difficult problem, but maybe we can move on and then come back to it later too.
Yeah.
Seems pretty hard to live solve. It's a good question though. Okay, I saw one question that I think is pretty interesting. I think it was Kelsey that asked, but the question is, where does the formula for the trapezoid come from? So let's see if I can make this question bigger. Okay. So I'm pretty sure that so a trapezoid looks like this. Well, it's something like this. The top two sides are parallel. And so I'm pretty sure one of the formulas is you take, so if this is base length of A, and then this bottom length is B, and then there's a height here. Does anybody know the formula for the trapezoid? Maybe you drop it into chat.
Isn't it like the two bases added together times the height over 2?
Yeah, A plus B times height over 2. And that's like, it looks pretty random, but there's actually like common sense behind it. So one way is you can split it into 2 triangles. Or not 2 triangles. You can split it into a rectangle in the middle and then 2 triangles on the side. So maybe I'll change my color for this just for fun. But okay, so the middle rectangle here would be equal to AH because this rectangle here has a height of H and a length of A. So this is AH. And then the 2 triangles over here, the formula for a triangle is base times height divided by 2. And then so if we look at this triangle and this triangle like added up together, we can say that the base length is B minus A because it's like this full thing minus the top part, which the leftover is B minus A as like the base kind of, and the height is still H. So base times height over 2. And then if we add these 2 together, it becomes this yellow formula. So we can try to do algebra on this, but AH plus B minus AH over 2. And then this can, or there's a number of ways to do this. Maybe there's enough space. So I'll just make a new page. Okay, and then it kind of becomes this. If you distribute it, BH over 2 minus AH over 2 plus AH. And then this middle, these last 2 terms right here become BH over 2 plus AH over 2 because it's AH minus AH over 2, so it's just half of AH. So this can also be written as A plus B times H over 2. So that's like kind of an algebraic way. Another way of thinking about it is if you have a, so let me erase this actually. So if you have a trapezoid, there's like kind of a midline right here. And this like middle kind of section is the 2 bases, the average of the 2 bases. So then it becomes like a rectangle. So you kind of split it up into like height times A plus B over 2, and A plus B over 2 is like the base of the rectangle. Not sure how to rearrange it specifically to get that. Maybe something like you take this triangle right here in the corner and then you move it all the way up here. So this becomes like this. I don't know. Yeah. Isha, is this like a good
work? I feel like more conventionally, like you'd kind of like flip it to make like a parallelogram. That might work as well if you wanted to like.
Oh, wait, you're right. That is a good point. Let's see if I can draw this. Okay, so trapezoid. And you said flip it, like so like here? Or no?
I feel like you just like flip it over like the long edge, right?
The
Wait,
long
would
A.
that work? No, that would form like a hexagon.
Wait, I think there is something to do with the parallelogram. Yeah, that's interesting.
Maybe you could like cut like the right side and then like move it. Oh yeah. Just like what you're doing.
Okay, so this part becomes a parallelogram, and the area for a parallelogram is A times H, I think. And then you have to find this area of this triangle. Oh, it's like what I just did, kind of, but like a different way. So if this whole part is B, but since it's a parallelogram, A is here, and then this is also A. Like this part is A. So then that part is B minus A. So it becomes a triangle that has base B minus A and then height H. Okay, that's pretty cool, actually.
Yeah, that's pretty cool. And it says, what if none of the lines are parallel? Well, in a trapezoid, like the like top base and the bottom base, they are parallel. That is like the definition of a trapezoid. So then we wouldn't feel like dealing with the trapezoid anymore.
Yes, then they would become like a different shape. So the formula probably wouldn't be true. Good question though.
Going to like a question I saw like a lot earlier in the chat. It discussed like the number of paths in a grid, and I thought this was a really interesting question because the counting was definitely interesting here. Like I'm just gonna draw like a sample grid just to like start off this question because that just makes it like a lot easier to understand. But let's say you start like at this point and you go to this point at the end here. So the goal here is to count how many paths you can get from start to end. And it might feel like a little bit difficult because you might be like, well, there's so many paths on how to choose. But in order to like minimize the amount of, and like a key point is that you can't go like backward, so to say. You need to go in like you can't go like, once you go up, you can't go down. And that brings up a really interesting point because essentially the path is from start to end is moving east and moving up. So that's where the formula comes from, because if you notice, this is like a 4x3 grid. So that means that you must move east 3 times, or that would be in the right direction. And then you'd move up twice. And it doesn't matter where you do that. Like you can move right, up, and then all the way right, or you could do like your ups first and then go right. So no matter what way you do it, you essentially always have 3 east and 2 up. So we could take this like path and then we can put it into like a string. So we can say a path is given up of 3 e's and 2 u's, no matter how they're arranged. And this brings up like the how many ways you can rearrange the string question, which is essentially just in this example 5 choose 2, because in a string of like 5 you're picking 2 of them to be you, so that would be 10. But in this example, that's how like you would get the answer. But in order to like generalize it, you can just think of it as choosing how many times you're moving right and how many times you're moving up. So just exactly like what Kelsey said, you can use factorials, saying 5 factorial divided by 2 factorial times 3 factorial. And cool thing, that is like the choose notation that I just did. So nice work on that.
Yeah, that's a pretty cool problem or idea.
Yeah,
and definitely. I think, yeah, I remember that in one of the classes actually.
Oh yeah, isn't it in like our combinatorics class, I think?
Something like that. I think so. Okay. We can move on to the next question then. Let me hunt for a question to solve. Okay, hopefully this one isn't too hard. I'm gonna take the most recent one I see from the Warrior Cats. So the question is, let A and B be positive integers. Oh, okay, sorry, wait. someone's telling me this is an IMO problem, that I should do it. Okay, thank you for the warning, because I probably would have sat here for a very, very long time. Okay.
I see an interesting question from person, which is how do you find the value of n choose 0, n choose 1, all the way up to n choose n?
Oh, okay. This is like Pascal's triangle, right?
Yep. I love Pascal's triangle. It's
Pascal's
so cool.
triangle is very interesting. There's a lot of cool patterns in it. Okay, so for people who don't know what it is, the Pascal's triangle is like you start with 1, and then like all the stuff on the outside is like 1s, and then it's like the sum, like this number would be the sum of the top 2 from before, like top right and top left. So 1 plus 1 is 2, and so then this is kind of like you can draw out, and it's symmetric, and so that's pretty cool. And there's like a bunch of different patterns, but this corresponds to like something choose something, this table, because this would be like 4 choose 1 over here. Oh no, sorry, 4 choose 1, 4 choose, actually no, 4 choose 0, 4 choose 1, 4 choose 2, and it keeps on going like that. So I think the pattern is Isha, is it like 2 to the n? That's the sum? Okay. Yeah. So I kind of forgot the proof for it though. Let me think.
I can explain it like real quick if you would like.
Wait, I think like maybe combinatorics. If you're choosing, it's like the ways of choosing 0 items from a pile of n items, or plus the number of ways of choosing 1 item, plus the number of ways of choosing 2 items. It's like all the subset of different combinations of items you can take from n things. I don't know if that makes sense, but like, so if you had a pile of like n items, and then you were like, n choose 1 would represent the number of ways to choose 1 item from that. And then n choose 2 would be the number of ways to choose 2 items from this. So if you add all of them up together, it's like the number of like different ways you can choose anything from it. So then that just becomes like, is this item included or not? So there's 2, like included or not included. And the next item, is it included or not included? So then you multiply 2 by n items, so it becomes 2 to the n. I don't know if that's a good explanation, but I think that was how I would think of it.
I never really thought of it that way.
What were you gonna say?
Like for me, like if you kind of like notice, if you like after like the first 2 rows, you always take the numbers above it and you add them together. So what you're always going to be doubling in the next row, because you're taking the sum and then like for all the numbers, and then you're adding like 2 to the ends. So you're always going to be doubling it, if that makes sense. But I guess like that's a more Pascal triangle related way. It's not really relevant to like the question itself.
I think it's like wait, what you said is pretty interesting. It's like inductive kind of.
Yeah, kind of.
That's pretty cool.
I definitely agree. Pascal triangle's amazing.
Yeah, I agree. Oh wait, it's like what Crow said in the chat. It's a number of ways to choose a subset from a set, which is 2 to the n ways. So that's
definitely. Oh yeah, like for example, like if you had like 5 balls and you wanted to choose like you wanted to see how many ways you can pick balls, like it doesn't matter if you have 1 ball or 2 balls. Basically the answer would be 2 to the 5, because you just, for every single ball, you pick whether or not it should be in the set or out of the set. I think, yeah, that's a really cool way of thinking about it.
All right. Next question?
Yeah, so
these are pretty good.
Yeah, I definitely agree. These are really interesting questions. Okay, the next question I saw was a question about Bob. So let's check it out. So it says Bob can buy 29 candies, and for every 3 wrappers of candy, which I assume that means that like every single time you eat 3 candies, though like you could have a wrapper with the candy itself. But how many candies can Bob get if he wants the most amount of candies? So essentially for every like 3 candies, you're getting 1 candy in return. So so you would just group 24 into groups of 3. Oh, no, but you need to consider the fact that you're gaining candies. Oh, this is interesting. All right. So for this one, I think it's kind of really similar to like the division trick when you're converting between bases, because like first you can take like 29 and you can like group them and you can divide it by 3 to get 9, because we don't care about the remainder. Well, we do care about the remainder, but like now you have like 9 candies left over, plus wait, no, I did something weird there. Yeah, no, yeah, you divide it by 9. So for each one of these like 9 groups, you get 1 more candy back. So that's gonna be like 9 plus like the 2 left over. So that's gonna be 11 divided by 3, and then that's gonna be 3 remainder 2, and then 5 divided by 3, which is going to be 1 remainder 2, and then you're gonna have 3 left over divided by 3 to get 0. Because what you're essentially doing is that like every single time you're for every like 3 groups of candy, you have like you get 1 candy in return. So you take that value and you move it down, but you still have like the candies that like weren't in the group. So that's like the remainder as you see here. And then all you need to do is take like the original number of candies and then add up this column. So that's going to be 29 plus 9 plus 3 plus 1, which is, so I can't, mental math is not my forte, but you get 42. So I'm pretty sure that's the answer.
Nice. All right. Do we have answers to this, or we just
I'm
like...
not sure. But if the
Okay.
person who like thought of the problem like wants to share the answer, then feel free to let us know what it was.
Wait, something interesting Kelsey said is that she heard us, or they heard a similar problem. A snail is climbing up a wall that is 12 inches. He can climb 3 inches in 5 minutes, but after he climbs 3 inches, he slides down 1 inch. How long does it take him to climb the wall? That's pretty interesting. Wait, I should paste this on here. I've actually heard of this problem before too. But we probably go over it real quickly since it relates to the problem Nisha just did. So I think like oh, this is the wrong. Give me a second. But I think the like catch to the thing is when you go up the wall, you can just exit. But then like sometimes if you go up the wall, you think, oh, it's gonna slide down. That will make more sense. Okay, let's see. So 3 inches in 5 minutes. But then after he climbs 3 inches, he slides down 1 inch. So he kind of goes up 3 and then down 1. So it's kind of like a net of going up like 2. So, but the problem with, or yeah, you can say it's like 12 divided by 2, but then the problem is that so there will be a point where the snail is at like 10, for example, and then they climb up 3 inches or something like that. And then you think the snail goes back 1. Okay, actually, this is 9. Okay, anyways, goes up 3, and the snail's at 12. So then technically the snail's like already out. But then if we divide by 2, if we do like 12 divided by 2, then we would think the snail goes back down 1 and then has to go up again. So I think that's where the catch is. But we can probably solve this real quickly. So let's see. Because he can climb 3 inches, I'm gonna calculate like how much it takes for the snail to get up to 9, 12 minus 3. So for the snail to get up to 9, it would be, I guess it gets up to 8 first. 8, and that would be 4 times 5 minutes, so that's 20 minutes. The snail's at 8. And then in the next 5 minutes, the snail goes up 3, so the snail's at 11. So this is the next 5 minutes, right? So 25 minutes, he's at 11. Oh wait, just kidding. Then he goes back down 1. So the snail's at 10. but then the next 5 minutes, the snail goes back up 3. So 30 minutes?
Yeah,
That was kind of messy. That was a little messy, but I think that works.
The idea that you had, like, with the fact that, like, at the end, that last 3 inches is going to go over was, like, right. But, like, in this case, like, the numbers work out so well that, like, 12 divided by 2 is just, like, 6. So, like, it's a whole number. So you, like, regardless or not whether you thought of that, you got the right answer.
That's true. That's true. But you gotta think about it though, because I think I've gotten tricked before on this problem. So
I agree. Yeah. All right. Okay. Oh, I see like a probability. I see a bag here. Let me paste on the screen for everyone to see real quick. We have a really nice like ball probability question here. So a bag initially has blue, red, and purple gumballs in a ratio of 2 to 3 to 4. And we added 5 red gumballs, and we want to basically see how many gumballs are in the bag. Oh, this is cool. Oh, I see. Okay, so I think what you want to like start out with is like the I guess like the probability, so to say, of that you get a red ball at the beginning. So that's going to be like 3 divided by in total I have 9. And then you're adding 5 to the like the gum bag. So you have whoa, wait. No, that's not going to be right. This is going to be 3x times 9x because we don't actually know how many balls are in the bag. And then that's going to be equal to 4/10. So what I'm doing here is I'm saying that, well, 3 out of like the 9 gumballs are going to be red initially because that's the ratio. We don't know how many gumballs there are because it's a ratio, so that's why I set x. And then we're adding 5 to the top and bottom because, well, we added 5 balls and the red balls, so it's what we want. And then the probability is now 4/10. So if we solve this equation, we're going to get 30x plus 50 is equal to 36x plus 20. So that's going to be 6x is equal to 30. So x is equal to 5. But the important thing to note here, I keep falling for this, but I'm glad I caught it this time, is that x is not what we're solving for. We're solving for how many gumballs are now in the bag. And if you realize, that is 9x plus 5. So 9 times 5 plus 5 is equal to 50. So that's actually how many gumballs are in the bag. So that's going to be our answer.
Nice. Yeah, that's a pretty cool problem.
I definitely agree. It kind of reminds me of like something that I think was in module 1 or 0. I'm not quite sure.
I think I remember. Okay, next problem. This one's pretty interesting. A triangle has integer side lengths 2, 5, and x. What is the median of all possible values of x? Okay, let me just draw this. So I think this has something to do with triangle inequality, which says like 2 triangle lengths added together, they can't be less than, no, they have to be more than the third length. And that's because like if you take 2 and 5 and you add them together, it has to be greater than this like dotted length. And if it's not greater than, then it would just be, if it's equal to, then it would just be like a straight line, which is not a triangle. And if it's less than the dotted line, then it can't be a triangle because it just can't exist physically. So let's see. We can do this in like equation form. So there's one inequality that we can already write, which is 2 plus 5 has to be bigger than, we can just say this is x. Oh wait, it's x. So 2 plus 5 is bigger than x. And then the other inequality we can kind of also write is 2 plus x is bigger than 5. Because, you know, it goes the same way for the other side. So 2 plus x is bigger than 5. And then we can also, like the third one we can write is 5 plus x is bigger than 2, but we already know that that's true because 5 is already bigger than 2. So 5 plus anything will still be bigger than 2. So we have these 2 formulas. And then from there, we can, from the first one, we know x is smaller than 7. So that's good. And then from the second one, we know x is bigger than 3. Okay, so that's good because we have like kind of a range of what x can be. So if we like draw a number line, 3 and 7, x has to be in between them. Bigger than 3, less than 7. X cannot be any of them though. So it can't be 3 and it can't be 7. So anything in between this. And it says, what is the median of all possible values of x? So, okay, x is an integer. So we can just we can take the average or something, but this is also pretty good because it's not too many numbers. So the middle median is 5, it looks like, for the possible values. But if it was like further apart and we didn't want to draw out a whole number line, we could have also just took an average. So 7 plus 3 divided by 2, which is also 5. So yay. Yeah.
Oh, cool. Yeah, that's a pretty neat question.
Triangle inequality.
Yes, I love the triangle inequality. All right. I have another cool question here that I saw in the chat from someone named A. And it's basically saying that you have a machine generates digits, and what is the probability that will generate a digit that is divisible by 14. And this is particularly interesting. I feel like there's 2 ways you could go about it. You could see whether like what's the probability that it'll get something with 7, and then always make sure that it ends with an even number because 14 is 7 times 2, but 7 doesn't really have like a neat like divisibility trick like 2 or 3. So I think that if you're anyways going to see like how many numbers are divisible by 7, you might as well just do it for like 14 itself. So in my opinion, the goal here is to count how many numbers are, because these are randomly generated, so the digits don't favor one or the other. So technically we're basically trying to see if a random number was given, or 4-digit number, what's the probability that's divisible by 14. So as a reminder, probability is like what you want over the total. So I think the total is definitely like a lot easier here. So that'd be 9999 minus 1000 plus 1. Plus 1 is because like when you subtract, it doesn't account for like the last number. So that's going to be 8999 plus 1, or 9000. That's just like a nice thing to know in your head that there's 9,000 4-digit numbers. Oh wait, I think I read the problem wrong. Thanks for pointing that out, Crow. It says generate 4 numbers that their product is divisible by 14. All right, scratch all of this work. And I think that it's, okay, that just makes it, in my opinion, a whole lot easier. Because all you want is, you need 7 in there. Because 7's like the only like 1-digit number that's divisible by 7. And then as for 2, you can take like, I guess, any of the numbers, like any of the even numbers. So that'd be 2, 4, 6, 8. And then for the other ones, you don't really care what they are. So the total number is still going to be, well, now it's not 9,000 because you're not generating 4 digits, but I think that it's easier to start with like what we want. So so here you're gonna like, you have to have 4 like 7. So you have to multiply by 1. You have 4 even numbers, so you have to have like one of those there. And then for the other 2, it doesn't really matter. And it doesn't say that like these have to be distinct numbers. So that's just gonna be 9 times 9. And then on the bottom, you can just have 9 times 9 times 9 times 9 numbers. So I'm pretty sure that's just gonna be 4/81 then, if I'm right.
That's a good problem. I'm not gonna lie, I also misread it the first time. But yeah, that's really good. We're gonna move on to the next one then. Okay, so Alice and Bob are playing a game on a 4-tile circular board. They take turns flipping a fair coin. If heads is flipped, they move clockwise, and if tails is flipped, they move across the board. The game ends when one player lands on a space where the other player is. The winner is the player who lands on the other player. Okay, if Alice flips first, what is the probability that Bob wins? Oh, this is fun. Okay, so we have a circular 4-tile board. So I'm assuming it's kind of like this. And they probably start like here or something. A and B. Okay, so I guess split into casework just to try first. So if Alice flips ahead, then Alice will be on the second. Okay, and we're trying to find the probability that Bob wins. So I guess we can just go with this for now. So if Bob wins on his first flip, then Bob flips also ahead. So that's like half a chance that Bob flips the same as Alice. And if Bob doesn't flip the same as Alice, then Bob goes across the board here, it looks like. So half plus maybe like something else. Crow says, would a probability tree be a good idea here? Yes, I think that would be a good idea. Maybe I'll draw one like to the side here. Although it would be hard because there's 2 people flipping coins, so that's like a big tree. But yeah, so if Bob flips it different, then it's either this. Let me think, like the alternate version would be Alice goes on this side, and then Bob comes here, but they're both like on similar things. Crow says we can notice a pattern to make the tree small. That's true. Okay, so all right, we can do it based on. So if Alice flips the head versus if Alice flips the tail. I don't know if this is the tree that Crow is thinking of. Hopefully. Okay. So it looks like if Bob flips a head also, then Bob wins. And if Bob flips a tail, then Bob also wins. If Bob flips a tail here, then Bob travels across the board. So it looks like B and A. And then what happens? Then Alice flips. So we don't want Alice to win. So the probably Alice has to go across the board here. Oh my goodness. Okay. I don't know.
That's interesting. I think that like has to do with something like how much you do in like 2 steps or something like.
Oh.
Maybe you have to do like something like repetitive, like some sort of like case, like geometric sequence or something like that, because they could keep like not touching each other for infinity.
Yeah, you're right. So like geometric sequence, let me think. Because there's like 2 cases where Bob, okay, Crow says the same thing. Bob is in front of Alice. So then if Bob has to win, Alice always goes in front of Bob. Because if Alice is behind Bob on any 2 of their, or at the end of a turn, then Alice has to go across. Because if she doesn't go across, then she'll win, which is what we don't want. So it's always B and then A, is what I'm thinking.
Oh.
So maybe that's something. So if we do like, if they're B and A, then Alice, it's the same thing again, isn't it? Alice goes across.
I have a question. I might be thinking about this wrong, but like if we're just flipping coins and also like either Alice or Bob has to win, and the probability that like you flip heads or tails is just 50%. So if one or the other has to win, isn't there just like a 50% chance that Bob's gonna win? Because
maybe, but Alice goes first though. So I think that's like,
that's true. Yeah, that could alter it.
Because Bob could win on the first flip, but Alice can't win on the first flip. So it's like a little skewed, I'm pretty sure. Let me think though.
Oh yeah, that's a good point. So we only really need to consider the first flip.
Yeah. Actually, I think that maybe the tree helps, like what Crow was saying. So, okay. In this case, if, let's just say like, oh, where's my finger? This case, Alice flips a head and then Bob flips a tail. then the thing would look something like this. Okay, wait, there we go. So then the probability of Bob winning, Alice would have to go across here. So the probability of Bob winning would still be like 1/2 if he landed on Alice, but then it'd be like the same probability if he went across. I'm not sure how to write that though.
Wouldn't it just be like multiplication similar to like 1/2, like depending on the flip, times 1/2 depending on where he moves?
Mm-hmm. Crow says make one branch end with an X. That is so smart. I think since it repeats like Bob and then Alice, this could be, let me think. Bob in front of Alice would be, oh my goodness, my brain is breaking on this problem.
I think the tree like was a good idea, but I feel like if you continue drawing the tree, then there's going to it's going to eventually go to infinity because they might just keep avoiding each other.
Mm-hmm.
Oh, Crow says wait for the pattern. Okay. But like just like Warrior Cat said, it is going to go to infinity. Okay, so go ahead.
I was gonna say what Kelsey said was really interesting. Game ends if someone goes sideways and not across. So 50% chance of Bob being the one to stop going across and win.
I think that like agrees with like what I was saying earlier, because one of them has to win, and all of this is like the chance that they land in a specific spot. So like we even like at the beginning here, like no matter like where Alice ends up, Bob always has a 1/2 chance of landing in the same spot. Because like if Alice only moves, yeah, exactly. So like I feel like it would be 1/2.
Okay. I don't know. It's a pretty hard problem, I think, because it's like so hard to think about. But I think the tree helps, and what you said also is like pretty helpful too.
I agree. All right. If you'd like, we might be able to come back to this question.
Yes, I think that's good.
Okay. I see the Monty Hall question in chat. I can quickly address that, but like, I think this question like was a long time ago, like before we talked about like Ragged's question, which was just like looking at identical socks. And this is, in my opinion, like really interesting because typically you have like 2 red socks, 2 blue socks, and then it just makes it easier because you have the same number of every sock. But in this case, you don't have the same number of every sock. So it makes it a lot more interesting. But in order to solve this question, I think you need to use casework. Because if you use like complementary counting, you're still going to have to consider the fact that like you don't have the same number of each one. So in my opinion, like there's like there's like, 8 blue socks, 6 red socks, 4 black socks, and 2 orange socks. And if you add them all together, that's going to be like 20 socks in total. And then you can just do casework from there. So you can be like, something important just before like I continue with this problem, we're going to have to use choose in this question because it doesn't matter which order you pick the socks in because they're identical. So that's just like something I wanted to point out before we get into the question. But anyways, the probability that you're like picking blue socks is going to be 8/20 times 7/20 divided by 2 because it doesn't matter which order you do it in. plus 6 times 20 times 5 times 20 divided by 2 plus 4 over 20 times 3 over 20 divided by 2 plus 2 over 20 times 1 over 20 divided by 2, all divided by, oh, let me scroll quick. All divided by 20 choose 2. That looks really big. Maybe make a case for having the two stocks be different from each other. That's a real, that might be easy. No. I think it'd just be the same number of calculations, because for each one of like the colors that you pick, instead of doing like picking like another of the same color, you'd be doing picking another color. So that'd be, oh, wait, something I just noticed here, that these are all supposed to be 19s because you already picked the stocks. But yeah, because like here, instead of like doing 7 over 19, you would do like 12 over 19, which means like you're not picking the same color. So I think it would like lead to the same result. So it just might be easier to just like solve for what you wanted instead of something that you didn't want. All right. I'm not really looking forward to solving this all out. Is there like an easier way to do this?
I mean, that's not too bad. Like, I would probably do it.
Oh,
let's see. 20 choose 2 is 20 times 19 divided by 2.
Oh,
so that cancels out a little bit.
Definitely. Oh, that's so cool. Okay, so thanks for pointing that out. Let me scroll up real quick because I need a lot of space for this. So this is equal to 20 times 19 divided by 2. So what we can do in this problem is that we can move this to, oh, wait, no, all of this just cancels out with each other. But then that wouldn't work, would it? Because like it's not a probability anymore.
Oh, wait, I think it is. The divide, oh my gosh. The dividing by 2 cancels out, but the 20 times 19 still stays as a denominator. It's just like squared, I think. Or it looks like.
Oh, yeah, you're right. All right, awesome. All right, so all of this cancels out with each other. So you're left with 56 plus 30 plus 12 plus 2 divided by 20 times 19 squared.
Yes.
Okay. 86. This seems like, I feel like there'd be like an easier way. Oh, wait, that's equal to 100?
That's kind of nice.
I feel like there has to be an easier way to solve this question now. But I won't spend time going into it because there's a lot of other interesting questions in chat that I know people want to get to. But that is equal to 4 times 19 squared, which I'm not going to do. I think this is good enough.
Yeah, that's good. That was pretty nice, actually. Like, it looked kind of complicated at first.
I agree, but it got really nice in the end.
Yeah. All right, next question. So this one is about an isosagon, something like that. So in a regular 20-sided polygon, all the diagonals are drawn. If a diagonal is selected at random, what's the probability of selecting a diagonal that is neither the shortest possible length nor the longest possible length? Okay, so we have this like random shape. I'll just draw a hexagon for now, I guess. And the shortest would be like from this point to like the closest vertex. So there's like 2 diagonals that are the shortest. And then for the longest, I think it's like, if it's 20-sided, then it's an even number of sides. So it would just be the diagonal because it cuts the sides in half, or the shape in half. So for each like point, there's 3 diagonals that we don't want to select. Yeah, what's the probability of selecting neither? So I guess if there's 20-sided polygon, how many diagonals would one vertex have? Probably like 17, I think. And I say 17 because, actually no. Yeah, 17, because it can't connect to itself, and it can't connect to any like surrounding vertices, the 2 surrounding ones. So it's 3 vertices that it can't connect to, but it connects to all the other 17 points on the isosagon. So it has 17 diagonals, and then 3 of them are some diagonals that we don't want to choose. So then this would be 14 diagonals that we want to choose out of 17. And I think that could be the answer because it would be the same for every point. Okay, Happy Mouse says you can do 20 times 17 divided by 2 because each line will be copied twice. Oh, that's a good point. Each line is copied twice. Okay. Although I don't know if that's a probability or not. So you have to divide by like the number of diagonals, right? I think this way works. I'm not sure though. Isha, what do you think?
I think that looks right because like, yeah, that looks right.
Yeah, I think it's okay because you're only looking at, yeah, what Kelsey said, you're only looking at 1 vertex. So you're not really double counting anything.
Yeah, if you're considering like all of them, you'd have to divide by 2 because there's 2 points that make up 1 vertice. But in this case, you're only considering 1 vertex, so it should be fine.
Yeah, if you did consider all of them, you would multiply it by 20 vertices and then divide it by 2 because each edge would be counted twice. So times 20 divided by 2. That's not a probability either. I guess both sides would be multiplied by the same number. Okay. I think it simplifies the 14 over 17 still. So that should be the answer. Cool.
All right. I really wanted to solve the hunting ball question because this has a really interesting like probability question like behind it, and also like it came up in like a camp I was doing, and I just thought it was like really fascinating how it applied to that sort of area. So all right, I think this is a cool question. So basically you're given 3 doors and one has like a car and then 2 has a goat behind it, and you want to find the and you assume that you pick a door. For example, let's say you picked this door. The host is going to reveal one of the doors with the goat. So in this case, they're going to reveal this one. So now you want to, and you're given the choice on whether or not you want to switch. So you want to see the probability that you're going to win the car, which is super interesting. And I'm just going to, and the idea is that you always want to switch, and here's why. At the beginning, you have like a 1/3 chance that you're going to pick the one with the car, because you don't know which one it is. But after they reveal it to you, then you technically have like a 2/3 chance, because like you still have 3 doors that you can pick, but you know it's not this one. So that increases like the probability that you pick the right door, because technically because you know it's not this one. That means like if you were to switch to this one, these kind of group into one option because you know it can't be this one. So you should always switch because the probability that you pick the right door increases. So I think that is basically the essence of that question.
It's quite interesting. I remember watching a YouTube video about this too, I think.
It's quite famous. All right. Do we have any? We only have 2 more minutes left. So is there like a question we could do like really quickly? Okay. I see Warrior Cats has like a adding question. Oh, it seems like an infinite adding. Oh, interesting. Wait, are you adding like 1/2 plus 1/2 squared plus 1/3 squared plus 1/?
I think the first term is 1/1 squared, but yes.
Oh, I see.
That's like the general pattern, I think.
Oh,
it seems very hard though, on first glance.
I feel like like this pattern comes up like a lot. It goes on like that. Did I get this right?
I think, yeah, that's right. I think it's like it has to do something with calculus.
Oh yeah, I remember.
Perhaps a little too advanced. I don't know. It is
Okay.
pretty hard. Okay, the warrior cat says it doesn't go to infinity.
I think this is like really similar to, we can probably like, since this problem involves calculus, I can solve like an easier version of this question where like you start with 1 and then you multiply by 1/2 every time. And the trick for this one is that it doesn't go to infinity either, because you set it equal to x. And then what you do is that you multiply like everything by 2. So that's going to get like, oh wait, let's ignore the 1 for now. We'll come back to the 1 in a bit because we can just add it at the end. So if you multiply everything by 2, you're going to get like 1 plus 1/2 plus 1/4 plus ... And then you'll notice that this part is the same. So you can just substitute x into this spot. So you get 2x is equal to 1 plus x. So x is equal to 1. Oh, wait.
No, that's right. Because then you add 1 to it.
Yeah. And then, yeah, because we started with the 1 at the beginning. So x would be equal to 2 at the end. Or that would be our answer.
Well, that's a good problem.
I agree. All right. So I think that wraps up our Ask Math Anything for today. Our next Ask Math Anything, I believe, is on Tuesday, if I'm not mistaken.
Yes, I think so.
Awesome. So if y'all are interested in, if we didn't get to your question today, we'll definitely get to your question on Tuesday. There's going to be 2 other amazing high school TAs. And until then.
I think the next one is actually on Saturday. So be sure to like show up on Saturday too.
Oh, okay. Cool.
Yes, at the same time, I think. 6 to 7 Eastern.
After this live solve ends, you're going to see like the time at the bottom. So even if we're incorrect, you'll be able to get the information.
Yeah. But yeah, thank you guys for coming. Hope you guys had a fun time. See you on Saturday.
All right. Bye.
Bye, guys.